All right, so we're diving into this research paper straight from the 38th conference on neural information processing systems.
Wow, 38th.
I know, right?
That's a lot.
It's quite a mouthful. The title is, get this, Unified Speech Recognition, a single model for auditory, visual, and audiovisual inputs.
Yeah, that is a mouthful.
So, I mean, in layman's terms, how would you sum that up?
Well, I mean, essentially it's about making computers better at understanding us, no matter what, no matter the situation.
Right, right. And these are, no slouches here. We're talking researchers from Imperial College London and Meta AI.
Yeah.
So some serious thinkers working on this problem.
Yeah, they are.
So let's kind of break down this challenge that they're trying to solve.
Sure.
And it seems like this whole idea of speech recognition has been kind of siloed, right?
Yeah, it's been quite divided. You've got, the audio side of things, think, like Alexa.
Right.
And then you've got the visual side, which is, like lip reading. And then, of course, you have the combination of the two, audio-visual.
Yeah.
And it's kind of in separate systems, It's like having different apps on your phone to do each of those.
Right. Yeah. It seems kind of clunky.
Yeah, yeah, very inefficient.
Like, why wouldn't it be one system that can handle all that stuff?
And that's really what makes this research so interesting. They're saying, hey, let's just have one model, a unified model that can do all three.
Okay.
So that's the big question they set out to answer. Can one model effectively handle all these different parts of speech recognition without losing performance?
Right.
Because, you might think, well, if it's trying to do all these things, it's not going to be as good as a specialized model. But they wanted to see if that's actually true.
Right. Yeah, that makes sense. So I'm curious, how do they even go about testing that? Like, is this a massive supercomputer they built?
Well, they actually started with a pre-trained transformer encoder-decoder model, which is, it's already a powerful tool for handling language.
Okay, encoder decoder. For those of us who need a little refresher, what exactly is that?
Yeah. So think of it this way. The encoder is kind of like a detective, right?
Hey.
Gathering clues from the input, whether it's the audio or the video. And then the decoder is like the writer, taking those clues and putting together the story, which in this case is, the transcript of what was said.
Oh, I like that. That's a good analogy.
Yeah.
But so how do you teach this one model to handle both sounds and visuals?
Yeah.
That seems kind of like, I don't know, teaching someone to juggle and ride a unicycle at the same time.
Yeah, it's pretty impressive. They use something called modality-specific feature extractors.
Okay.
And you can think of those as like specialized translators.
Okay.
So one for sight, one for sound. And they convert the raw data into something that the encoder can actually understand.
Oh, okay.
Yeah.
So they're basically teaching it to not only understand those separate pieces, but also to integrate them, like kind of like how our brains work.
Right, exactly. We use both what we see and what we hear to understand speech, and this research is trying to mimic that same process.
Wow. Okay. So they're really pushing this model to be more like us.
Yeah, and what's even cooler is they found a way to use data that's unlabeled.
Unlabeled.
That means it's audio and video, but without transcripts to help the model.
Huh. So it's like giving someone a puzzle, but with some pieces missing.
Exactly. It forces the model to fill in the gaps based on what it already knows. They use something called pseudo-labeling, where a teacher model, one that's already been trained, creates labels for the unlabeled data. So the student model can learn from a much bigger set of examples.
Oh, that's really interesting. So the teacher model is like a tutor.
Right, exactly.
Okay, so they're really throwing everything they can at this. But did it work? Like, did this whole ambitious approach, did it pay off?
Well, the results are really impressive. This unified model actually beat out existing methods on some standard benchmark datasets like LRS3 and LRS2.
And are those using separate specialized models?
Yeah, even those that are trained just for one type of input.
Wow. So one model doing better than multiple models trained for specific things.
That's right.
That's remarkable.
And it gets even better. They tested it on the wild VSR dataset, which is known for being really tough, like real-world conditions. And again, the unified model came out on top, surpassing all the other methods.
So what does this mean for the future of speech recognition? Like, is this a game changer?
It could be. Imagine a world where your devices understand you perfectly no matter what. If there's noise around, if you're whispering, or even if you rely on lip reading.
Okay, now I'm really intrigued. This is starting to sound like something out of like a sci-fi movie. Like,
Right.
what are some specific implications you could see from this kind of breakthrough?
Well, for starters, I think it could lead to more inclusive tech for people with hearing impairments. Think about better accuracy in those automated captions or voice control for those who might have mobility issues.
Right. Yeah.
But it goes beyond accessibility, too. Imagine giving commands to, like, robots in a noisy factory or your car understanding you perfectly even with the windows down.
Right. Wow.
So it could really change how we interact with machines in general.
Wow. Okay. So we've covered the research question. We've talked about how they went about this, this whole testing process, and some pretty incredible findings.
Yeah, and we've only just scratched the surface. There's still a lot to explore,
Right.
like how to refine those pseudo labels and how to incorporate even more data to make this model even better.
Okay.
But I think one thing's for sure.
Yeah.
This is a huge leap forward for speech recognition, and it has some pretty big implications for the future.
Absolutely. Um, I'm already thinking about all sorts of other questions, like, well, what are the limitations of this approach? What about the ethical implications? We've got to unpack all that and more.
Definitely, there's so much more to dive into.
All right, well, we've covered a lot in this first part of our deep dive. What else should we explore next?
Well, I think it would be fascinating to dig deeper into those failure cases.
Oh, yeah. You know what? You're right. Those errors the model made, those could hold some really important clues.
Absolutely. They might reveal something fundamental about how machines learn and how they differ from us.
Okay, yeah, I'm totally on board with that. Let's delve into those failure cases and see what insights we can uncover.
Sounds good to me.
All right, we'll be right back after a short break. Don't go anywhere.
One thing that really strikes me about this research is how much it mirrors, how our own brains work.
Oh, yeah. Tell me more about that.
Well, think about how we process speech. It's not just hearing the words, right?
Yeah.
We also look at lip movements, facial expressions, even body language. All those things feed into how we understand what someone is saying.
Yeah, definitely. Like, if you're in a noisy bar, you kind of have to rely on lip reading
Yeah.
a bit to follow the conversation.
Exactly. Our brains are constantly taking in all this information, both auditory and visual, and blending it together seamlessly. And that's essentially what this research is doing, teaching a machine to do what we do naturally.
So by training this one model on all three types of input, audio, visual, and the combination,
Yeah.
they're enabling it to learn those subtle connections, right?
Yeah, there's connections between sounds and lip movements that our brains just kind of pick up on without even thinking about it. It's
Uh.
not just about being more accurate. It's really about replicating the way humans understand speech, which is far more complex and nuanced than just processing words.
And that's probably why this unified approach is getting such good results, especially in those like tricky real-world situations.
Yeah, exactly. The model is using all the information it has, just like our brains do, to make sense of what it's seeing and hearing. It's like giving the model a superpower to adapt to different situations and still understand what's being said, even when information is missing or distorted.
Yeah. It makes you wonder if this could help, people with hearing impairments in ways we haven't even thought of yet.
Absolutely. Think about the possibilities for language learning, too, right?
Hmm.
Being able to see the lip movements along with hearing the words, it could make learning a new language so much easier.
Yeah, that's true. It'd be like having a built-in language tutor constantly showing you how to say things correctly.
Right. And even how we interact with those virtual assistants could change. Imagine showing your assistant a recipe and it knows what you need without you even saying anything.
Or like pointing to something on your screen and having it respond. Wow, that could make our interactions with technology so much more intuitive. All these incredible possibilities, and we've only just scratched the surface. But, thinking about all this advanced technology, it makes me wonder.
What's that?
Well, we've talked about the good stuff, the potential benefits, but are there any potential risks? Anything we should be thinking about?
Yeah, that's a good point. Any powerful technology has the potential to be misused, right? I mean, we're basically teaching machines to understand and process information like we do. Could they eventually start thinking like us too? What would that mean?
Yeah, that's a pretty big question.
Yeah, it's a question that's been around for a long time,
Mm.
and this research definitely adds fuel to that fire.
It really is mind-boggling.
It is, but that's part of what makes this so interesting. This research is pushing us to ask those big questions, explore those unknowns, and really confront those fundamental mysteries of what it means to be human. And that brings us to a really interesting point they mentioned in the paper.
Ooh, what's that?
They talk about these failure cases.
Failure cases.
Yeah, instances where the model, despite all this advanced training, made errors.
So even with all that data and computing power, there are still things machines have trouble with.
And it's fascinating. Most of the errors were related to distinguishing between sounds that are phonetically similar, like this versus these or disguised versus denies.
So even with all the advances, they still haven't quite mastered those subtle nuances of human language, those things that, we just do naturally.
Exactly. It's a good reminder that some things still make us uniquely human.
Maybe our ability to understand language, with all its little quirks and complexities, is one of those things. It makes you wonder if, in trying to teach machines to speak like us, we might actually learn something new about ourselves.
It's like we're holding a mirror up to our own minds, right?
Yeah.
And it reveals things we might not have even realized about how we think. It really makes you appreciate how incredibly complex and amazing the human brain is.
It really does. This has been an incredibly thought-provoking conversation. I think we've covered a lot of ground here. Should we move on to the final part of our deep dive?
Yeah, let's wrap things up by digging a little deeper into some of these things we've been talking about.
Okay, so we were just discussing how even this really advanced model makes mistakes, especially with those subtle distinctions in language.
Right. And those failure cases, they're not just, glitches or bugs. They're actually pretty insightful.
Yeah. So what can we learn from them? What do they tell us?
Well, I think they highlight just how complex human language really is. Even with, tons of data and all this processing power, machines still have trouble with the nuances that we take for granted.
It's like they've got the grammar, they've got the vocabulary, but they haven't quite figured out the poetry of it all. How meaning can change based on context, tone of voice, even a slight inflection.
Exactly. It really underscores how much we still don't know about how our own brains process language.
So even though this, unified model is a big step forward, it's also a reminder of how far we have to go to really, truly replicate human intelligence.
Yeah, for sure. And it raises that big question, right? If we can teach machines to understand language this well, can they also learn to think like us? Develop consciousness, emotions, creativity.
Now, those are some big questions. I guess that's part of what makes this research so fascinating. It's not just about, building better gadgets. It's about exploring what it means to be human.
And it's forcing us to confront the ethical implications of, creating machines that could potentially be as smart as we are.
Right. It's exciting and a little bit daunting at the same time.
Yeah, it is. But I think that's what makes it so compelling. We're entering this uncharted territory, pushing the boundaries of knowledge and wrestling with these profound questions about our own existence.
Well said. It really makes you realize that this research is about so much more than just building better speech recognition. It's about understanding ourselves and the world around us.
And who knows what other amazing discoveries are out there as we learn more about the human brain and the potential of AI.
Yeah, it's an exciting journey, one that I'm definitely going to keep following.
Me too. It's a field with so much potential. I can't wait to see what the future holds.
Well, this has been an incredible deep dive. We've talked about cutting-edge research, the complexities of the human brain, and even the philosophical implications of AI. It's been thought-provoking, inspiring, and honestly, a little mind-blowing.
Couldn't agree more. It's always a pleasure to chat about this stuff with someone as curious and insightful as you.
And to you, our listener, thank you for joining us on this journey into the world of unified speech recognition. We hope you enjoyed it as much as we did.
Until next time, keep those questions coming, keep exploring, and keep those minds working.